symmetric proofs. That might be the worst. But.
They may or may not have that radian question on it.
Oh yeah, that's what she said. So.
Not legally, I mean talking.
Right. We're going to talk about what is a radian today, how it relates to degrees, because most of us think about circles and angles in terms of degrees, but in trig and in calculus, we talk about radians, so we're going to talk about what that means, how do I convert, and we're going to talk about how to break down degrees into smaller units, and I'm going to show you how your calculator does that for you, and that you don't have to think too much about that, but some uses of it. All right, so here we go. This is the definition of a radian, which really is not that important, but to say what is a radian, if you have a circle, the central angle, and this is all geometry stuff that's been forever, you know, when did you take geometry? 2 years ago? 2 years ago? Ninth grade? Central angle is an angle that is in the center, right? There's the radius. If the central angle of a circle has a measure of 1 radian, if it intercepts an arc, this would be the arc, with the same length as the radius. So notice, this would be your radius, it's labeled A, and this would be the arc labeled A. So anytime you have the radius that is the same length as the arc, that's 1 radian. Never in my life am I going to ask you that question, but people always say, where does it come from? What does it mean to be 1 radian? So I want to give you that definition. What we're going to use radians for is converting between, most of us know what 90 degrees looks like, so how many radians is that? So that's the kind of stuff that we're going to do with radians. We're going to give our answer in radians, and so we're going to get a lot better with them as we go through them. But that's the definition of what a radian is if you are interested. It is a hand-drawn circle. Go back and check it out if you want. Like this was the angle, and someone was struggling seeing that, so then I just went around the angle to try to make a circle where that's sort of the center, but it's not really perfect if we analyze it too close. Just look at it quickly. Keep going. Circumference. Circumference and area of a circle are those formulas that you've learned since probably upper grade school, middle school. We don't use it a lot. People get confused a lot. But just to try to relate this to where does this come from, the circumference of a circle is 2 pi times radius, or pi times diameter. But we're going to talk about radius. So let's keep it in terms of that. If the radius equaled 1, right? If the radius was 1, which is what we call the unit circle, that would just give you 2 pi, because the radius would be 1. Everybody with me on that substitution there? So here's what's really cool. How many degrees are in 1 revolution of a circle? 360. So in 1 revolution of a circle, we know there are 360 degrees. In radians, 1 revolution of a circle is 2 pi. So to get around a circle, it takes 2 pi radians. You don't have to put radians after this. So here's a really important thing to learn in this class. This symbol means degrees. If you write an answer and it doesn't have a degree symbol, then it's assumed to be radians. Does that make sense? So like if you write an answer like this, but you really mean 45 degrees, but you write that, it's going to be wrong, because if there's no degree symbol, then in math we assume that the answer is in radians. So you have to make sure you put that degree symbol for degrees. If it's in radians, usually it's in pi, terms of pi, but not always. Sometimes it's a decimal. You don't have to put radians after it. Does that make sense? Okay. So let's think about this. If 1 revolution of a circle all the way around is 360 degrees, or 2 pi radians, let's do degrees first. We do better with degrees. How many degrees would halfway around the circle be? 180. Half of 360 is 180 degrees. What would half of 2 pi be? 1 pi, or I'm just going to say pi. Have you done this before in the year? What grade did you do this in, like 4th grade? In physics? Okay. He's like, no, 5th grade. What about a quarter of a revolution? Quarter would be like, let's think about if we broke this up, right? A quarter would be like this much. How many degrees would it be from here to here? 90 or 360 divided into 4 quarters would be 90 degrees. Or what would be 1/4 or 1/4 of 2 pi? 1/2 pi, or we like to say pi halves. Math people. You'll get there. You're almost a math person. Once you start speaking in radians like this, you'll be officially a math nerd. Colin, I bet you just joined this just so you can hear the unit circle song again.
Yeah.
Here, look, I have one more here just for fun.
60.
1/6, you're just going to take 1/6 times 360, which is 60 degrees.
Somebody else.
You just take 2 pi times 1/6. It's just pi thirds. Eventually, in a few days, or who knows how long if the weather is terrible, we're going to draw out some big circles, and I'm going to show you how we can break this up. And probably, even if you don't learn trig, you're going to get a lot better with fractions, because you have to think about breaking up a circle into different pieces. And, remember the old days of like shading in how much of a circle? Well, kind of what we're going to do to teach you how to read in terms of radians, so that you're not having to convert every time. These are all equal, right? 360 is equal to 2 pi, 180 is equal to pi. So anytime you're converting, oh my gosh, I'm going to kill myself. You could use any of these, but usually what we use is this as our conversion factor, right? 1 pi radians is equal to 180 degrees. So a big part of your homework today is just converting, so let's practice doing that. And so I said degree radian conversion. We know 180 degrees is equal to pi radians. And so your book actually gives you this, which I think is silly. I'm going to show you how you can just think about it when you're doing it. But it says if you want to convert radians to degrees, you're going to multiply by 180 degrees over pi radians. And they wrote radians there just because we're new to this. It's the same conversion thing you've always done, especially in chemistry or when we're converting feet to miles, right? We say there are 5,280 feet in 1 mile. Sometimes the 1 mile's on top and the 5,280 is on the bottom, and other times we switch it because it just depends on how your units line up. That's the same thing with this. 180 degrees is equal to pi radians. You could do 360 degrees is equal to 2 pi radians, but it just reduces down to that. And so that's your conversion factor, and so once you know that, you can convert very easily. So let's practice with this. And so I wrote this. This is my shorthand version of it. I always know I'm going to be multiplying by one of these. How do I know? Go back to my chemistry days and say, I need the degrees to cancel out, so I know I want the radians on top over 180 degrees, because then my degrees would cancel out and my new answer would be in radians. Yes? Any clue what I'm saying? Don't multiply by pi, because we want to give an exact answer, and so leave it in terms of pi. We like to give answers like pi halves and pi fourths. So just reduce your fractions here, or you can do it on your calculator with a fraction, but the degrees would cancel out, and that's just, what, 12 and 18, 6 goes into both of those, so that would be 2 and 3. So that would be the same as 2 pi over 3, or 2/3 pi if you want to be not a math person. 2 pi over 3. And think about what that's saying, right? In terms of where would that be? Most of us can visualize degrees way better than we can visualize radians right now. But if I know half of a circle, that's terrible, is pi, then 120 degrees is 2/3 of the way of half of the circle. Does that make sense? Which would be like, here's 90, so 120-ish. Like that would be my angle. All right, sorry, get ahead of myself. You do 20 degrees. Ready to go. Can I throw calculators at you? It's not bad out. The weathermen were wrong.
You got 6.5 inches and no more.
Don't lie.
Okay, Sawyer on text said 6.5 inches in his house.
That's a lie.
I believe it. Maybe it's Who's sunny home?
I don't even think it's supposed to be bad today.
No, it's supposed to get really cold tonight. It's the only issue.
-2 or something like that.
But like the wind chill's gonna be like -30.
That is tickling me. Like it's too cold? Oh, I didn't know we had to like
If it gets super, super cold,
because they can't have gases and stuff.
yeah, I don't know, but we'll see. Mrs. Hodge said after last year when we came to school so much, she thinks they're never going to call it again. We came on some pretty bad days last year. We missed so much.
I don't think delays are gonna be a deal. I don't know why they freak out. We still get to count it.
I hate delays because we only have
I
25
love
minutes.
the I get to sleep in 2 more
I
hours.
love the lazy because you don't have to make it up.
I'll get the schedule for you. It's 25 minutes. 25-minute classes.
I like the lazy.
Are they really? That's it?
Oh, I already got one.
Yeah, that's 2 hours.
What is that? Pi ninths? Yeah, and think about 20 degrees. 1/9 is a small fraction, and so that makes sense that that's only pi ninths of the way around. Okay, so today is just try to get you comfortable thinking about this, and then then I'll throw some crazier stuff at you.
So we only leave it like that.
Yeah, we leave it like this. I'll give you one in a minute that we wouldn't leave like that. Okay. What about if I want to go from radians to degrees? And again, how do I know these are radians? Not just because there's pi in there, because sometimes there won't be pi. I might make a new example here.
Multiply times 20.
But I know this is a radian because there's no degree sign in it. But yes, Grady, you're right. If I want to make this go to degrees, then now I need 180 degrees on the top, and I need my radians to cancel out. Usually your pi's will cancel out, so that works out really nice. But that's how you know which one to do. Like, I don't feel like you need to memorize, I multiply by 180 over pi when I do this, and pi over 180 when I do this. You just think about what you're converting to, just like you've been doing for years in chemistry and math classes as well. Again, really nice, the pi's cancel out. 6 goes into 180 30 times. So 7 pi over 6, I believe, should be 210 degrees. And notice that you have to put your degree symbol there. Let's see this. 105 degrees, is that true?
What's the rest of that?
I'm making a new one. We're going to call this so my numbers don't get messed up. This is 4A. Let's call this 4B. What if I said 2.7? Right? That always throws people for a loop because they say, one, is that radians or degrees? Because there's no degree sign. Yes? It's okay to have a decimal for either radians or degrees, but 2.7 means they've just multiplied the pi in there and they've rounded it. I'm still going to do the same thing. I'm still going to multiply by 180 degrees over pi. But this would be an example that I would say don't leave pi in your answer. It's already a decimal. Divide the pi out and just round to whatever 2 or 3 decimals, or if it was a test, whatever the directions say. But that would be an example of something that I would say don't leave it in terms of pi. Pi's in the bottom. 2.7 times 180 divided by pi, I get 154.7 degrees, I think, if I round to 1 decimal. Or even 2, I would get 0.7. Okay, so don't be thrown off by that. Everyone always has a question on ones like that. So some really nice degrees, some not so nice. Okay? Now you know what radian is. You should go back to that test. Okay?
You can do calculus.
No, I got this at a garage sale for $2 a few years ago, and it didn't work because it didn't have batteries in there, or the batteries were dead. But I was like, hey, how much is the calculator? And it was like, I don't know, a couple bucks. I was like, okay, and I gave her the money and left really quick because I really didn't do it.
How much does it run?
Over $100.
You are a scam.
I did not put the price. I asked how much you want.
Over $100.
Usually, what are they? You can get them on sale before school starts for like $89.
Ask Brad how much this costs. This one that has Pokemon on it. This light up colorful screen.
Over $100.
How much is the battery for?
It's just 4 AAA batteries. And so, like, I took the chance. Like, I could have paid $2 and got home and it didn't work, right? Because apparently she didn't know how much it cost.
Why is it green? Where do you get a green calculator?
I don't know.
I guess so, but I was gonna say
Like, oh, at least get spot.
No, I was just like, okay, here you go, and I just went to the car and waited. Yeah, like I was like done. There wasn't. I looked around. Well, I looked around really quickly, and then I was garage selling with Mr. Ricky, who none of you know, but he used to teach here. Mr. Ricky and I used to go garage selling a lot together, and I was like, I'll be in the car. And wasn't my fault. Okay. It's not like I said, hey, I'll give you a couple bucks for this. Like, she said the price. Okay, one other thing that we're doing today, degrees and radians, really, really important. We're going to do it over and over again. The other idea is that instead of giving your answer in just degrees, you can give more specific degrees and break them down. So if one revolution of a circle has 360 degrees, how many degrees would be 1/360th of a revolution? One degree, right? You can actually break 1 degree down even more, and it's really weird and people really struggle with it because we talk about it in terms, we say minutes, all right? We say degrees, minutes, seconds. I don't mean minutes and seconds like a clock. It is the same name, but it just means more specific than just rounding to the whole degree. So in 1 degree, we say there are 60 minutes. Works out really nice because there's 60 minutes in an hour, right? 60 minutes. I believe that there's, it's just like a apostrophe thing.
That's feet.
Not in degrees, minutes, seconds. So we can say minutes. And then in 1 minute, guess how many seconds there are? 60 seconds.
1 second.
And you put 2 little things on it. And you say seconds. Where is this used? When giving latitude and longitudes, especially in terms of navigation, people sailing boats or people flying planes, instead of giving decimal latitude, longitude, they give degrees, minutes, seconds. If you've ever looked up on your phone or on an app and you've tried to find something, usually it shows you like a latitude, longitude. Have you ever seen something like that? Like 120 degrees, 47 minutes, 12 seconds.
I just thought that I never knew.
Yeah, degrees, minutes, seconds. And so that's a more exact way, or just the way navigation people use it. I don't know. I don't know why we use degrees, minutes, seconds as opposed to decimals, because it's the same thing. You're just rounding it off, I guess. But that's what it's used for. So if you're not going to be a navigation person, are you really ever going to use this? No, probably not. But I've taken college courses, and I'm teaching college course right now, that this is in there. So it's something that you might see again in your future, and so it's nice to at least be aware of it. The really cool thing is that scientific calculators have a button that you can use to convert degrees, minutes, seconds, so you don't actually have to do the conversion. I'm going to show you the conversion, at least so you can see that it's just the same thing that we do with pi over 180 and 180 over pi, but I'm not opposed to using your calculator either, because even if I don't show it to you, a couple people are going to figure it out, and then it won't be fair that some people know there's a button and some people don't know there's a button, so I'm just going to show you that there's a button. Okay. This one's really easy because it's just 0.5. But throughout this book, randomly they'll throw a problem in terms of degrees, minutes, seconds instead of decimals, and so we usually are just converting, and so that's another reason that I show it to you. But if you're converting using degrees, minutes, and seconds, you want to take the decimal part and turn it into minutes or seconds. So the whole part, the 27 part, that's the degrees. It's going to say 27 degrees. But I want to convert the half a degree into minutes and or seconds if needed. This one you can kind of use common sense on, and then I'll show you the conversion. If 1 degree has 60 minutes, how much is half a degree going to have? 30, right? How would I get that? I would use a conversion factor if I wanted to do the math. I would say, I know there are 60 minutes in 1 degree. How do I know to put the 1 degree on the bottom? Because I want the degrees to cancel out, right? The same conversion thing that we've always been doing. And 0.5 times 60 is 30 minutes. So 27 degrees, 30 minutes. Just to show you, see if I can find this button. First of all, something we need to notice on our calculators is if you turn your calculator on my calculators, at the very bottom it says DEG, which means degrees, right? Yes? attention because sometimes we'll be in radian mode, sometimes we'll be in degree mode, and if you're in the wrong mode, you miss lots of points on your test because you're in the wrong mode, and then your test corrections are full of hate and anger because your calculator was in the wrong mode. All right, we're not going to use that mode right now, but I just want to throw that out there. D, E, G. Oh, okay. At the top, some just have a G. Let's see.
DRG on top.
ERG?
Yeah.
Don't change it. You don't need to do anything right now. Sorry I mentioned it. We're not there yet. Leave it alone. It won't affect if you change it right now. It doesn't affect your answer. On my calculator, right below the delete button, there is a degree symbol, a minute symbol, and a second symbol. You see that right below delete? If you type in 27.5 and you hit that button, you'll see there's a degree symbol, a minute symbol, and a second symbol. We don't need that. But scroll all the way over, and there's it has like a triangle, and it says DMS. That stands for degrees, minutes, seconds. So if you type in degrees and you hit that button, it will give you the answer as 27 degrees, 30 minutes, and you don't have to put 0 because it's 0 seconds. Every calculator is different. So if you don't have a calculator like mine, you need to look for that button, or when I'm done here, I can come around and try to find it for you to do it. All right, so try this one on the calculator. It's two calculators. Under math.
Well, we just get one of the 3 points every time, just a big whole number. Get that right.
And so I used to make people show me the work on this, and then I just gave up. So that's what happens after a while teaching. You just get defeated. Yeah, you'll have the calculator. That means there's only going to be like 2 questions, so don't.
I think it's 1.5. Crazy teacher.
I typed it in 1.7. If you need help with your calculator, see me in a minute, and I'll help you. Okay? The other one is going the other way. Maybe let's see. If they give it to you in degrees, minutes, seconds, you actually have to type it in if you're doing it in your calculator as degrees, minutes, and seconds. So you'll use that button for degrees, minutes, and seconds, and it should give it to you in decimals. Let's see. I don't ever use the calculator, so I don't know the answer to this. Degrees, so 315 degrees, and I'm going to hit 48, and I'm going to hit minutes, and I'm going to hit 3, and I'm going to hit seconds. Yeah, and I just hit enter, and it gives you a really, really long decimal. This is why navigation people use this, right? My answer is 315.8008333, and it actually is a repeating decimal. And so it's hard to give that as an exact location when you are navigating, and so that's why degrees, minutes, seconds are used. So if you're going to be in the aviation field or boat field, I don't know what that's called, sailor field, then you will use this. Otherwise, you probably won't use it, but if you ever see latitude, longitude, you'll at least say, oh, I know what that means. But it says round to the nearest hundred, so that would just be 0.8 if we rounded that off to the nearest hundred with the degree symbol on it.
So it's like 2 decimals?
Yes. Since that's all it says. What? Questions about that? That's not so bad today. Alright, this is 4-1 day 1. I don't have an assignment sheet for you yet, but you are going to do 2 through 24 even. Tomorrow we will talk about what else we can do with these degrees and radians, talk about arc length, talk about area, angular velocity, see how fast the Ferris is spinning, some exciting stuff like that. And then 4-2 is when we're really going to do some good trick stuff. This first section I don't really enjoy that much, but it's always something that.
You know, nowadays they make clocks.
It's just, I don't know, I feel like it doesn't show up as much. Like these couple things when we review for the final, you're going to have forgotten about minutes and seconds and angular velocity because it just doesn't show up that often in the rest of this class. So 4-2 is when we get into unit circle.